This video is presented to you by www.testprepadda.com. Dear students, in the previous session of kinematics, we have derived three equations of motion. V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. These equations we have derived when the particle was moving in a straight line and with a constant acceleration. Now I will tell you how to use these equations when the motion is on a plane or even three-dimensional motion. Consider a frame of reference, this, and this origin as 0, 0, 0. And consider the position of the particle at time t is equal to 0 as origin. Okay, now I'll break the motion into three independent straight line motions. So if 2D is given, we will break that into 1D. X direction, Y direction, and then last Z direction. Here I'll write dvx by dt as ax. Here I'll write dvy by dt is equal to ay, and here I'll write dvz by dt is equal to az. Okay, ax is acceleration in x direction, ay is acceleration in y direction, and az is acceleration in z direction. So motion of the particle is broken into three independent straight line motions. And equation wise I can write Vx is equal to Ux plus At, X is equal to Ut plus half Ax t square. Here also it will be X. Vx square is equal to Ux square plus 2Ax into X. Similarly, I'll write Vy is equal to Uy plus Ayt, and Y is equal to Uyt plus half Ayt square, and Vy square is equal to Uy square plus 2Ay into y. Here also it is Ux. Now Vz will be written as Uz plus Azt, and Z will be written as Uzt plus half AZT square and VZ square is equal to UZ square plus 2 AZ into Z. Okay, now to understand this, I'll take a question here. Here the question says, a body is initially at the origin and in a state of rest. The body is made to accelerate by, acceleration is given in meter per second square as 1 I cap plus 2 J cap plus 3 K cap. Find out, number one, velocity of the body after 1 second. Number two, coordinates of the point after 1 second. We will break this motion into three independent straight line motions with constant acceleration. I'll write here X, Y, and Z. For X, t is equal to 0. At t is equal to 0, x is 0 and ux is 0. Ax is given as 1 meter per second square. So, after 1 second, at t is equal to 1 second, I can get Vx as ux plus axt. So that comes as ux is 0, ax is 1, t is also 1, so it comes as 1 meter per second. Okay, and the x coordinate I can find, x is equal to uxt plus half axt square. If you substitute the values, you'll get half meter. Similarly, for y direction, at t is equal to 0, y coordinate is 0 and the initial velocity is also 0. Here the acceleration is given as 2 meter per second square. So Vy at t is equal to 1 second will be how much? Use the formula uy plus ay into t. Uy is given as 0, ay is 2, t is 1. So it becomes 2 meter per second. And y coordinate uyt plus half ayt square. Uy is given as 0 and ay is given as 2. And that is why it will become 2 meter, sorry, 2, this is half at square. So 2 into t square is 1. That is why it is 1 meter. For z, at time t is equal to 0, uz is 0. Az is given as 3 meter per second square. So Vz will be found here as uz plus azt, and if substitute, it comes as 3 meter per second. And z coordinate you will find as uzt plus half AZT square, and if you substitute values, you'll get 3 by 2 meter. So, what will be the velocity at time t is equal to 1 second? The velocity will be written as I cap plus, you can see 2 here. So, 2j cap plus, you can see here 3. So, 3k cap. And what will be the position vector? The position vector can be written as half I cap, you can see here half, plus j cap, you can see here it is 1, plus 3 by 2 k cap. Okay. Now suppose in the question initial velocity is given. For example, let us say initial velocity is given as 2k. If the initial velocity, let us say initial velocity is given as 2k, you can see here the x and y components are 0, 0. Only z component is given. So only z direction will be different. Got the idea? For example, if the initial velocity is given as 2k, then at t is equal to 1 second, you can get vz is equal to how much? Initial you will write 2, that is uz plus AZT, and if you substitute AZ as 3, then it becomes 3 into 1 3, 2 plus 3 becomes 5 meter per second. Dear students, equations of motion can also be used vectorially. I can write here v vector is equal to u vector plus a vector into t. I can write s vector is equal to u vector into t plus half a vector into t square. And the third equation I can write vector v dot vector v is equal to u vector dot u vector plus 2 a vector dot s vector. Here, this u is initial velocity vector of the particle. This v is velocity vector of particle at time t. S is what? Displacement vector of the particle in time t. Okay, now if the initial position of the particle, let the initial position vector of the particle is r naught, then at time t, the position vector can be written as r naught plus u vector t plus half a vector t square. It's very easy to define because the displacement vector is what? The displacement vector is position vector at time t minus initial position vector. Got it? This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.